Hi Year 10, me again for our last lesson on Pythagoras, which is problem solving. Now when we're problem solving, some of you may find it difficult. It's one of those things that a lot of people do struggle with in maths. So it's always good just to have some steps to follow to help you out. Now I've got 6 steps here that you can use if you choose. I think it's a good idea though. So the first thing you need to do with any problem solving question, if you can, draw a diagram. Mark any known lengths and, as it's Pythagoras, your right angles. Use a symbol like X to represent the side you're trying to find. Do your Pythagoras, solve the equation, and then write your answer in sentence form if necessary. Just some information about some shapes here. So a rectangle, if you draw a diagonal in a rectangle, you're going to get 2 right angled triangles. Same with isosceles and equilateral triangles. If you split those in half, you'll create 2 right angled triangles. And with squares and rhombuses, if you join the corners and do two diagonals, in the middle you will end up with 4 right angles, and each triangle will be the same size with a right angle in the middle. So first example, we have a rhombus that has diagonals of length 6 centimeters and 8 centimeters. Find the length of its sides. So remember, in a rhombus, all sides are the same length. It's like a square, but just on a slant. And it tells us here that it has diagonals of length 6 centimeters and 8 centimeters. So its diagonals just go straight through the middle, there and there. And obviously the longest one is 8 centimeters and the shortest one is 6 centimeters. And we have right angles for each triangle. I'm just going to draw it on one though. As all triangles are the same size, we only need to work out our distance of one of its sides by using just one triangle. Now this triangle here, I'm just going to black that out in pen there, is going to have a length of 4 here and 3 there because it's halfway between the length, it's half the length of the 4 diagonal on each side. So as the long one was 8 centimeters, half of that is 4. The length of the diagonal was 6 centimeters, so in the triangle it will be 3. And we are trying to find the length of the side here, so I'm going to label that X. Now if we look at this here, we're trying to find the side opposite the right angle, which is our hypotenuse. So in our equation, it means we're going to have x squared equals 3 squared plus 4 squared. Which means we're going to have 9 plus 16. So x will equal 20, x squared will equal 25, and x will equal 5. And then just write a sentence. So the length of the sides in the rhombus are 5 centimeters. Example 2. A 50-meter rope is attached inside a cylindrical wheat silo of diameter 12 meters. How high is the silo? Now with this, what I would maybe do is just take this triangle that you can see inside. If you see it here, let me draw on that in pink. It's given us a triangle here already in the diagram. So what sometimes is a good idea to do is just draw the triangle on its own without everything else around it. And so we know it's a right angle there, this side's 12, this side's 50, and we are wanting to find the height. If you want to use H for the height, go for it. Use X, pick a letter, doesn't matter. I didn't really do it in the question before, but remember, we should really define our variable. So I'm going to say let the height be H. Sorry, be X meters. I've used X. Be X meters. Now if we look at here, building our equation, the side opposite the right angle is our hypotenuse, so which is our C, so it'd be 50 squared equals x squared plus 12 squared. From here, we can just expand that, so 50 squared is 2,500, 12 squared is 144. If we rearrange this, we're going to get 2,356 equals x squared, and then the x is going to be approximately 48.5 meters. So it's not an exact value, we do need to round it. And then we can just write that as a sentence. So the silo is approximately 48.5 meters high. So nothing too crazy, just simple. Draw your diagram, work through the problem, and go from there. Got two more examples. So next one, a room is 6 meters by 4 meters and has a height of 3 meters. Find the distance from a corner point on the floor to the opposite corner point on the ceiling. So this is a 3-dimensional problem. So we're going to need to draw a diagram. So we've got a room and it's 6 by 4 and a height of 3 meters. So it's going to be a rectangular prism type of shape. Now we're going to have some fun drawing this. I probably should have drawn this earlier. So this is going to be the front of my room. This will go back. And then I'm going to use dotted lines for the other parts. Yeah, that's not too bad. All right, so we have this room here. We know it is 6 meters by 4 meters. So I'm going to say that this is 6 meters, this is 4 meters, and the height is 3 meters. We want to find the distance from a corner point on the floor to the opposite corner point on the ceiling. So I'm going to draw this in black, and I'm going to go from the floor point here, where you see the black dot, to the top corner there. And that's going to be my triangle. So I'm going to be going down to here, and then this is going to be the triangle that I am trying to find out. Because it's obviously a 3D shape, what you would find is that is actually a right angle there. And I'm now going to draw this triangle out of the example. We know the height of the room, which is this side, is 3. Now we don't actually know what the length of either of the other two sides are, so we have to work that out first. Now if we look at the floor of this room, with the black line going across the floor, here, I'll draw an orange next with this bit here, the floor is a rectangle. And then we're wanting to find this distance across the bottom of the floor, which is Pythagoras in itself. So let's call this side here x. So to work out x, we're going to have x squared equals 4 squared plus 6 squared. Which will be 16 plus 36, which will be x squared equals 52. If we go back to our big triangle now, okay, and we are wanting to find the distance from the bottom corner to the top corner, so we're trying to find this side here. If you look at the black triangle, we want to find that y. We know that this bit here will actually be the square root of 52 if we were to have solved the previous equation. Now if we can work out y from this now, we've got enough information. So y squared is going to equal 3 squared plus the square root of 52 squared. So up here, if you wanted, we could say that x equals the square root of 52. Now 3 squared is 9, square root of 52 squared is just 52. So y squared will equal 61, so y is going to equal the square root of 61, which is approximately 7.81 meters. So that distance from the bottom corner to the top corner is 7.81 meters. So 3D problems can get a bit tricky. Just take it step by step, draw a diagram, look at what you know and what you don't know, and go from there. Now the last example, a pyramid of height 40 meters has a square base with edges of length 50 meters. Determine the length of the slant edges. So let's try and draw this diagram. So it is a pyramid of height 40 meters and it has a square base. There's my lovely base. I'm going to have my point at the top here, which needs to go to that side there. This one can go to that side. We need that to go to that side, and this one to go to that side. It's got a height of 40 meters, so there's this height in the middle. So the height is the top point to the middle of the square base, and we know that that is 40 meters. And each of the edges is 50 meters. Now we're wanting to find the length of one of the slides. So I'm going to use this back one here as an example where I'm going to label it Y. We want to find the length of that. Now if you look here, we can make this into a nice lovely triangle, which would be a right angle here. But once again, as before, we need to find the length of this bottom side, which I'll call X. Different ways we can work out the length of X. So you could look at this base as a whole square and work out the whole length diagonal and divide it by 2, or you could make it into a smaller right angle triangle, which would be half the length of a side, and go from there. So it's your choice really, but what I'm going to do is I'm going to do it as if it was a whole. So if we were to look at the whole base, this is the base of the triangle that I'm drawing now, which is the square, which has sides of 50, and this diagonal across, where that's the middle of the base, and we've already called this half here X. As it is a square, it means this side here will also be X, and then we can work out the length of one side from there. So if you think that whole diagonal is going to be 2x squared equals 50 squared plus 50 squared, or if you wanted to, you could have just made this into a small triangle here, which would have been 25 and 25. It's your choice. So this would give us 4x squared equals 50 squared plus 50 squared, which is 5,000, and x squared equals 1,250. X will equal the square root of 1,250. So we now have the length of x, which means now we have a second triangle to work out y. So I'll do this one in orange. So this would be the triangle with the height across here. So in this one, our height is 40 meters. The base is the x, and we are trying to find the slant here, which is the hypotenuse. So y squared is going to equal the 40 squared plus x squared, which is going to equal 1,600 plus 1,250. So y squared is equal to 2,850. And you do the square root of that, and you are going to get approximately 53.4 meters. So each slant edge is about 53.4 meters long. That is the end of our content and theory for Pythagoras. You are now able to go and do 6E and 6H from your booklets. If you have any problems or questions, just email teachers. There's some questions there that could make you think a bit. That's okay. I really want you to give them a go. The only way you get better at problem solving is by practice. Always give things a go. Don't be afraid to make a mistake. If you make a mistake, we can then work out where you went wrong. If you don't attempt things, then we don't know what you know and what you don't know to be able to fix it. Okay? So good luck with the rest of those questions, and I will talk to you soon.